Welcome to PentaTorch, an optimization platform for planning and response under uncertainty. This brief walkthrough shows how PentaTorch jointly optimizes an integrated operational plan and scenario-ready response playbooks, keeping decisions aligned when conditions shift while minimizing the risk response cost. PentaTorch illuminates decisions across the Uncertainty Pentagon's 5 dimensions, so teams can respond confidently and efficiently as conditions shift. Learn more at PentaTorch.com. This is the data setup page, where I connect to a data source and prepare a dataset for solving. First, I choose the data source mode. I can work from a database connection or upload CSV or Excel files when needed. When using CSV or Excel, the app validates the inputs as they are uploaded and can also write the validated tables into the database. The database is organized by schema, so input datasets stay structured and consistent. On the right, the preview panel confirms the connection and shows a dataset summary, so I can quickly verify what is available and ready to use. Finally, in Prepare Dataset for Solve, I select a dataset and click Stage for Solve to load and stage it for the optimization engine. This step runs solve readiness validations, so the data is consistent and complete before optimization. This section shows how an optimization run is configured. First, the Model Options bundle, then the Engine Options bundle. On the Model Options page, I create a model bundle that captures the solve policy. For example, I can set the primary objective and choose demand fulfillment behavior from strict fulfillment to service level bounds. I can also define network design policy, like fixing the number of open distribution centers or enforcing existing facilities, along with other operational controls such as disruption handling and inventory guardrails. On the right, I can review existing bundles and inspect save settings, which makes policies easy to reuse, compare, and audit across cases. Here, I select the execution configuration. This bundle defines the scalable engine profile, such as a core engine for general instances or a large-scale mode design for high DC candidate cardinality, and the inventory scope, either integrated time phase inventory with the network or a network-only variant. I then choose the solver and set performance controls such as time limit and optimality gap to balance speed and solution quality across different run sizes. Together, these bundles create clean separation of concerns. The model bundle defines the decision policy, the engine bundle defines how it is executed, and the same bundles can be reused across datasets and cases for consistent, repeatable results, while also improving flexibility for configuring user-specific runs and making differences in outcomes easier to trace back to exactly what changed. This is the case management page, where I create cases and monitor execution from end to end. On the left, I create a new case by selecting 3 components: the data instance, the model options bundle, and the engine options bundle. This makes each run explicit and repeatable because the case is always tied to specific dataset, solve policy, and execution setup. I can also delete a case from here when it is no longer needed. In the middle, I can load 1 or 2 cases for execution view and side-by-side comparison. Each case card summarizes the configuration and a compact snapshot of the instance, so it's easy to confirm I'm working on the intended run. Below that, the workflow is organized as a clear sequence of procedures: initialize case and scenarios, structure uncertainty, and run optimization solve. Each step shows its status, so it's easy to see what is completed, in progress, or not started. Finally, the right panel lists existing cases for quick access. The key value of this structure is flexibility with traceability. I can keep the same dataset and swap model or engine bundles, or keep the same policy and swap datasets to run controlled comparisons and clearly understand what changed behind different results. On this page, I'm defining the uncertainty structure for a case before running optimization. Structured uncertainty is important because it makes volatility explicit, comparable, and auditable, so the optimization is solving the right problem under clearly defined operating conditions. On the left, I select the case and review the registered scenarios. Each scenario has a short business description, so it is clear what it represents and how it differs from the others. In the View Filter section, I can slice the uncertainty by lens and time view, for example segment versus behavior and season versus phase. I can also filter by period, product category, customer category, supplier category, transportation mode category, and DC category. This helps validate uncertainty where it matters, rather than relying only on a single global view. Across the top, the uncertainty range gauges provide a quick snapshot of the variation captured for the 5 key drivers: demand, supplier price, sell price, transportation rate, and DC available capacity. In the main panel, the Uncertainty Pentagon radar chart visualizes all 5 dimensions together, scenario by scenario, so it's easy to compare the shape of uncertainty, not just the magnitude. Finally, the DC availability table provides an operational check for the current view, showing how DC capacity and supplier availability behave under each scenario and time slice. This page is the bridge between data setup and the optimization solve. It makes uncertainty structured, reviewable, and decision-ready. This is the operational plan page, where I review the optimized plan in a way that is both decision-ready and easy to validate. At the top, I select a case. The page supports side-by-side viewing, so I can compare 2 plans, either different datasets, different model policies, or different engine settings, and immediately see how the operational outcome changes. The KPI panel summarizes the outcome at a glance: the objective, selected DC count, and the major financial totals, along with a compact cost breakdown covering production, procurement, transportation, inventory holding, and fixed operating costs. This gives a quick business read before drilling into details. Below that, the network map visualizes the footprint and flow structure. It shows which facilities are active and how material moves through the network, which is useful for sanity checks, like confirming the selected DCs and seeing whether lanes look reasonable. Under the map, filters let me focus the view by distribution center, supplier, customer, period, transportation mode, and product. This is important because real plans are large. Decision makers need to zoom into a specific slice without losing the overall context. Further down, the plan summary section provides a structured roll-up of a plan: production, inventory, inbound transportation, and outbound transportation, all reported in the base unit of measure. In addition, the demand section shows scenario-level demand for the selected view, which helps connect the plan back to the uncertainty structure. Overall, this page is built for operational clarity. It combines a management-level summary with drill-down validation, and it supports controlled comparisons, so it's easy to explain why 2 plans differ and what that means for execution. This is the scenario response page. It explains not only the optimized plan, but also how the plan changes when a specific scenario occurs. At the top, I select a case, and then select a scenario. The page shows the scenario occurrence rate, so the analysis stays grounded in likelihood, not just impact. The first section is cost breakdown. On the left, I see key totals for the case, and in the main panel, I can compare the expected cost structure against the cost structure under the selected scenario. The transportation chart breaks cost down by mode and direction, which helps diagnose whether risk is being driven by inbound, outbound, or a specific mode. Next, in scenario outcomes, I choose metrics to plot and compare scenarios side by side. This makes it easy to see how key KPIs, like cost, revenue, profit, and other operational and risk metrics, shift across scenarios. The distribution view supports CDF, cumulative distribution function, and PDF, probability density function, which helps quantify downside risk and variability instead of relying on a single point estimate. Further down, the DC capacity section connects the response back to feasibility and operations. I can filter by DC and period and see available capacity versus processing load and inventory. This is a quick way to spot bottlenecks and understand where the network is stressed under the selected scenario. Finally, the scenario realization view shows the operational adjustments in a structured way: production, inventory, inbound, and outbound, split into the base plan versus scenario pullbacks and boosts. That separation is the key value. It turns scenario analysis into an execution-ready playbook, showing what needs to increase, what needs to be deferred, and where the adjustments occur in the network and over time. This is the risk exposure page. It summarizes in one view how much additional cost is driven by uncertainty and what is driving it. At the top, I select a case on the left and, optionally, a second case on the right for side-by-side comparison. Each side shows the case identifier and a compact breakdown of how the total risk response is allocated across major cost drivers. Each tile answers a single question: how large is the risk exposure for this metric relative to the operational plan? The gauge shows the relative magnitude, and the values below separate base, expected, and the implied risk response difference. This makes it easy to interpret risk in both percentage and dollar terms. 4 cost tiles, like total cost, procurement, transportation, production, and inventory. The small chart underneath shows how the outcome varies across scenarios, so you can see whether the risk is broad-based or driven by a few tail scenarios. Revenue and profit tiles are shown as line gauges to highlight directional impact, whether uncertainty creates upside, downside, or both, without mixing scales with cost. The value of this page is speed and traceability. It turns scenario results into a clear risk bill, highlights which drivers matter most, and supports clean comparisons across cases, so it's easy to explain why one configuration is more resilient than another.